everybody, and thank you so much for joining us here on this live stream on my YouTube channel. Now, I'm going to kick off this live stream series of She Can Cloud Native with a very special guest, Divya Mohan. Before we go to Divya and hear from her and hear about her story and what she's going to talk about on this live stream with us, I want to thank the sponsors of this live stream, which is Aqua Security, for giving me the time to work on this live stream, as well as Commodore. Commodore is an all-in-one DevOps platform where you can basically manage all of your Kubernetes workloads, your infrastructure, your Helm and Kubernetes manifests, debug processes, and much, much more. It's a very versatile platform. They have a free tier as well. It's not just a paid platform. So do check out Commodore as well as their Helm, open source Helm platform. They do some very great stuff also with their open source tooling. Anyway, let's head over to the live stream and to our topic today. Hi, Divya.
Hi, Anais. Thank you for having me on here. It's a pleasure, and I'm really glad we could do this today.
It's actually the first time we're doing something like that together, which is
Yes.
really exciting to me. And that's also why the live stream started a few minutes late, because we were talking so much about life and traditions and festivals. So yeah, this is great. This is amazing. Could you give everybody who's viewing an introduction, overview of who you are and how come that you are on this live stream that I asked you to join? I personally don't like to introduce people because I feel like they can introduce themselves much better. So I would love to hear from you of who you are. Yeah.
Absolutely. I think we're on the same page there because I also, if I'm hosting a live stream, I typically tend to ask people to do that as well. So, So hello, everyone. And thank you, Anais, for having me on here once again. I'm Divya Mohan, and I am a Senior Technical Evangelist at SUSE. So one of the, things that I do, apart from the open source stuff that I work on at SUSE, is co-chair the docs for Kubernetes and the Litmus Kiosk projects. I was also CNCF ambassador, and spoken at a bunch of conferences and virtual events and in-person events, internationally and locally. So I guess pretty much the reason why I'm here is A, because Anais invited me, and B, I will never turn down an invite to talk with her because we don't get to catch up all that often. So yeah, that pretty much explains the reason why I'm here.
Amazing. So how come we are talking about cloud native WASM?
Right. So this is a very strange pivot from my side. Like, I never expected to run into WebAssembly heads on.
Yeah.
Like, I'm the last candidate to actually have done that because I come from a systems engineering background, and even before that, I come from an electronics engineering background. My programming knowledge is like basic level at best. So WebAssembly should typically never have been on my radar, but honestly speaking, Cloud Native WASM caught my eye during KubeCon EU 2021. That was 2 years before shit 2 years before. And what happened was that I was really fascinated about this whole concept in general, about how they were trying to bring how WebAssembly as a framework was trying to bring more languages to the web and solve the problems of JavaScript. And I started watching the re-recordings, not re-recordings, the recordings of the event after the event got done, because obviously I did not attend that event since I didn't know much. Then I was like, hey, this is an interesting space to get into. To be honest, by the end of 2021, I was like, I am going to learn Cloud Native WebAssembly. And I announced it publicly, and I was like, I am going to learn Cloud Native WebAssembly publicly. And you know what? I'm going to document my journey. And I think after that, there was no looking back from there. But that's been my whole journey. Like, I've tried learning in public as far as possible after entering into open source. So yeah, that's how my Cloud Native WebAssembly journey began. And why we're talking about Cloud Native WebAssembly today is because it's a very interesting space. A lot of discussions are happening in the space, whether or not it's going to replace containers, whether or not they can work together, whether or not there is a future for WebAssembly in cloud native. So
Yeah.
lot of discussions. If you look at tech Twitter or even LinkedIn right now, it's crazy. So I
Yeah.
think it's a topic as good as any to talk about today.
Amazing. To be honest, the first time I've heard about WebAssembly was when I was working in the cryptocurrency space before changing into the cloud native space, because the project I was working with, they used WASM as like their runtime to on their blockchain. So the things I know so little about it, and also at the time I was just hardly putting the pieces together in my role there. But basically, you could then write applications for that blockchain, like decentralized applications, either in TypeScript, so similar to JavaScript, or in Rust. So for people who don't know Rust, it was a great alternative, and both of them would be able to run on that blockchain, right? And that was kind of the first time I heard about WASM. But when I then got into the cloud native space, it was like, how does that relate? Like, why would somebody use that in the cloud native space? That was, yeah. So when you proposed to talk about it, I got very interested. I also didn't watch any of the recordings so far from the previous WASM days, which is, I guess, a little bit of a miss.
That's okay. You can start anytime. It's not like it's going anywhere. Yeah, it's
Yeah.
not going anywhere. You're still going to be very much a part of this industry, so it's okay. We can always start learning right where we are right now, so it's not a problem.
Awesome. Also, what do I just want to say? Because of that, I have lots of questions for you. Yeah, awesome. If you're watching this and you have any questions throughout the live stream, throughout the presentation that we're going to see in a second by Divya, do post them in the chat. We will see them. I don't know if the chat works. I think you have to be subscribed. I hope it works. You just have to be subscribed, and then you can comment. If somebody who's watching right now would like to just say hi in the chat so I know it's working, that would be amazing. Otherwise, yeah, do you want to share your presentation? Alistair is watching. Hello, thank you. So now I know the chat is actually working, because that's, I guess, the most frustrating. The chat is not working. Yeah, also, if you're watching the recording, you can always comment below any questions that you're having. I'm going to go ahead and share your presentation.
Yeah, that wasn't the intended effect.
No?
Clearly. No, there were like clouds floating, and now the effect is ruined. So
Oh no!
and
Can
I
you
was
fix
like,
it?
no, I just want to just see. Let me.
Did I
It's
share the
there. It's
presentation you sent me? Is that easier?
Let me just check. That's a PDF, so might not really work. So let me just check if I can.
What is it supposed to show?
It's supposed to show like yeah, this is what it's supposed to show. Like if this is it's a
The
movie.
first slide is not.
Yeah.
We're not talking about a music band called Cloud Native WebAssembly.
Yeah. So I can do one thing. I'll just 1 second. Let me
Take your
do
time.
one.
We have all the time in the world. There's no rush.
Yes, I know. I'm sorry about this though. I do not know. I think it's
Don't
because
worry.
yeah, I think it's because I had that moving image instead of a static image. I should have realized that that's not the right thing to do.
Oh,
But
that usually happens, when you add a GIF or GIF,
yes,
depending on how you want to pronounce it,
yes,
to your slides, and then something doesn't work as expected, or you show this, you show the slides, and it's not actually. Nothing is moving, and it's just this weird stagnant image that nobody will understand, and it's not conveying the joke it was supposed to convey.
So I'm gonna try coming
If it's
from
just the first slide, we can use this now.
yeah. So that's fine. Not a problem. So honestly speaking, if you can go this way, I'm fine presenting. Or yeah.
Can you?
Yeah.
Yeah, computers is still very much a mystery. Today I was in a Zoom call and with non-tech people, and we were trying to figure out how to make somebody as host. And they thought, because I'm working in tech, I should know.
Yeah. So I mean, I can start off. This is probably the
Okay.
only slide which has like a wavy thing, but it's fine.
Can you click
So
or should I click? Just so I
let
know
me
how
just,
prepared I have to be to click. Okay, you
yeah,
can click. Awesome.
I can click. Yeah.
Okay, please go. The stage is yours.
Thank you so much once again. And sorry about all the mess up.
No, no
Hopefully,
worries. There's no mess up.
yeah. So, like I said, we are in a very interesting space today when it comes to WebAssembly and Cloud Native. Primarily because there's a lot of discussion ongoing, right, as to whether there is a necessity really for WebAssembly to make its mark in the Cloud Native space, whether it's going to replace Docker or containerization or whatever. So that's the whole idea behind this presentation slash session, so that I hopefully can demystify some of those questions and clarify them. And like I said, Cloud Native and WebAssembly are like, I wouldn't say they're two different ecosystems, but they really are. Because Cloud Native, it's basically a different term, and WebAssembly is a different term. So the amalgamation is a little intersection of ecosystems. So we're going to take a look at each of the ecosystems differently, see where they are at right now, and then see how they intersect and probably can help better the future of application development and I mean in general application development. So first up, when we talk about Cloud Native, the very first thing that Cloud Native is famous for is Kubernetes. But honestly speaking, Cloud Native is a way um, you know build and develop applications. It's a way of going about, it's a different way of going about how you do your application development, building, deploying, and management and stuff like that. So what these tools that like Kubernetes and Prometheus and the rest of them allow you to do is to build, deploy, and manage your applications in a format that could be um, you know deployed across public clouds, private clouds, or hybrid clouds. And uh, on and you would be able to leverage the benefits that come with each of these cloud providers, or each of these options rather. And the whole idea behind Cloud Native is to do all of this in a cloud agnostic fashion, not tying down yourself to one particular cloud provider, say AWS or GCP or whatever. So that's the whole idea behind Cloud Native as a paradigm. um, so some popular cloud native technologies obviously are here on the screen. But like everyone's favorite is Kubernetes, or maybe not everyone's favorite, it's the most popular one. And what why is Kubernetes everyone's favorite, or it's the most popular one, is because it was one of the first it was the first project that was donated by uh, you know, Google to the Linux Foundation as the seed project for the CNCF. As of now, it boasts of a massive global contributor base, is the de facto container orchestration tool, and is also, a very popular open source project. So yeah, so that's one of the cloud native tools. The others on the slide are also probably logos you're familiar with. Prometheus, which is the second, which was the second project to be accepted after Kubernetes into the CNCF. And it has helped shape monitoring and observability as we know it today in the cloud native space. The rest of the tools, I'm not going to detail every tool, don't worry about that. So you have the key value store HCD, you have the runtime container D, and you have like the cloud native package manager, which is Helm. But if you thought that cloud native was just these 6 7 tools, honestly you couldn't be like farther from the truth, because the landscape I have specs, but I'm pretty sure anyone without specs also cannot see what is there on the screen right now. So I have prescription glasses, by the way. So I definitely cannot even understand where Kubernetes is on the landscape that is visible on the screen right now. So irrespective of how, how much you enlarge it or whatever, it is not visible because the landscape currently boasts of 170 plus projects, 800 plus members, members as in member companies, and 1,80,000 plus contributor base, and this was as of 2022. So you can see that cloud native is not really going anywhere in terms of how our industry is adopting it. But when we talk about cloud native with respect to industry adoption, right, where are we? Most of us, like at least I come from a background where we've been deploying applications across data centers, and those data centers were owned by us, like by us in the sense the companies that I worked for. But that is the background that I come from. And most large enterprises that like your banks or like your financial institutions, or even basically large enterprises in general, are still making that transition from a virtual machine based workload to a containerized workload. uh, but why was that necessary in the very first place? Like, I get the fact that I'm here to talk about cloud native. Why was there a requirement for cloud native to actually come into the picture? So one of the things that you sort of um, realize when you think about where why we are here is, we also have to jump back into the past and think about how we ended up here. So we started out with like um, running workloads, applications rather, on dedicated servers in our very own data centers. We had full control of them. Once we actually realized that we had to scale out our applications, and it's not going to be just like one or two applications that we're running, we realized that that was not going to be like a feasible option from a cost and a resource perspective, which is when we stumbled into the virtualization game. We started with a hypervisor, which gave the level of abstraction of a VM, wherein we sort of divided up a single server into many virtual machines, and those virtual machines ended up running our workloads. Now, from a resource perspective, this sounds really great, because if a single server can host multiple VMs and can host like a lot of workloads, it's effective from a cost and a resource perspective, right? But unfortunately, anyone who's actually run workloads on a virtual machine will definitely attest to the fact that if you run into a production issue when running these workloads on these virtual machines, uh, your environments where you sort of need to debug, like the lower environments where you probably want to debug and test stuff before pushing them into production, look nothing like the production workloads, like the ones that service the customers. This could, like, cause massive troubles when you're troubleshooting and trying to resolve um, issues with customer facing applications. And to an extent, I guess standardization in environments, right? With its promise of portability and with and the various standards that come around with containers. Um, now when we talk about containerization and cloud native, we aren't just going to transition our workloads to containers and stop right there, because we have a really really long way to go with respect to the kind of workloads we are running recently. We want to be closer to the customer. We want our applications to run on a variety of devices, and those devices look nothing like servers in a data center. So we're not stagnating right here. We want our containers and our applications to run on a variety of architectures. So what essentially happens, because you need this to happen, you need like the last level of that last layer to be abstracted away as well. I say this in all good faith that if anyone's actually tried running containers or managing containers on any environment other than Linux, it's a struggle. And I say this with all with the best of intentions at heart. It's not like there are no good alternatives. There are alternatives which are decent, but the user experience doesn't really match up. And as a result, what happens is, it's a struggle when it comes to actually um, you know customize and rewrite and reconfigure just so that your application and your container can run on different operating systems or different architectures, because that honestly is where we are going towards. And what is required at this point is for last level, that is the host agnostic framework, which will help take away all the host based dependencies, and just allow you to actually write your code once and run it literally anywhere. That's where we all started from, right? As an industry, write once, run anywhere.
Could
So
you give an
yeah.
example of host specific dependencies?
Right. So, host specific dependencies, in the sense when you need to run your application. Um, it's the simplest thing again. Um, when you need to run your executables in a Linux environment, and when you need to run your executable in, say, a Windows environment, you have different set of files, you have a different set of commands, you have a different set of binaries that need to be downloaded for each of them, right? Like, it's a struggle, like a little struggle when I was starting off, because I have a Windows machine as my daily driver. And for the longest time, I did not understand why I was not able to start up stuff easily. Like, everybody was just like running Kubernetes and doing stuff. Like, I know that there's WSL and there's Vagrant and there's VirtualBox and stuff like that, but I was like, why doesn't it like run on Windows? Like, it's not a bad thing. But I realized that it's different for different operating systems. You have to do different stuff and different customizations. So for example, I don't think I think Vagrant has there's a lot of reconfiguration to be done when it comes to the Apple chip, not and you can only run it on the Intel chip. There's a specific thing wherein Vagrant needs a lot of reconfiguration to be done if you are using it along with the Apple M1 chip and not the Intel chip that normally people tend to use when it comes to Apple. So yeah, so that's a host specific dependency, but it's a very basic one. But again, like you have different binaries you need to work with. You have different you have entire different uh, configurations to work with when it comes to a cloud native workload running on a Windows machine and a Linux machine. So there's a difference, and there's a difference in developer experience as well. So that's what I talk about when you're abstracting away that last layer. And that is where we are at right now. Like, we do not really have that developer experience that matches across operating systems, across architectures. And hopefully that's something we can cover in the next couple of slides, and I'll show how it works. So that's where we are at when we talk about WebAssembly. But so not WebAssembly, cloud native. But when we talk in the initial slide, the session and the name of the session, I said that it is related to cloud native WebAssembly, right? So what is WebAssembly, and why is there so much hype around such a thing that is named web and assembly, very strangely? So This is direct copy paste from the WebAssembly or website. I have not changed up anything, but to put this in simple, very simple English, WebAssembly is just a binary instruction format. It's not like your fancy high level programming languages with all your frills and fancies. And it's essentially because of this binary instruction format, the form that it is in, that this framework is portable across architectures, and it it has these various benefits that we'll cover in the next couple of slides. So once we talk about WebAssembly, the name itself has web in it, right? So does it mean that, WebAssembly is only for the web, and it cannot be extended to, say, server side environments? And really, can Cloud Native and WebAssembly find their groove and help us better developer experience? Um, so we'll find out in the next couple of slides. But before that, if you remember the slide where we stopped at with respect to Cloud Native, you remember that we were requiring a host agnostic framework, right? So um, WebAssembly sort of does that with its binary instruction format that's portable across architectures, operating systems, and you literally just have to write code and run. You just have to write once and run it anywhere. That's the promise. But honestly speaking, uh, you know the benefits are pretty apparent. You have a binary instruction format, which means that it's not really tied to the architecture above it or the operating system above it. So it's obviously portable, and compared to say a container image, which has like the minimum size container image that you can think of, it will have a longer startup time. And if you do not design container images well, you will have a really long startup time. So compared to that, the fundamental unit of WebAssembly is a module, which are extremely tiny owing to the format again. So the modules are extremely tiny, and as a result, their speed of execution and the size are relatively smaller. It's actually even been proved via experiments and benchmarks that the speed of execution can sort of reach native or near native speeds. And the fundamental unit that I was talking about, the module, it's by definition a sandboxed environment, which means that you can which means that it cannot exactly you know be prone to malicious actors or attack vectors, making it do things that it should not be doing. The reason being, the module can only access the memory it has been assigned. And if you want to know the list of features that it's probably going to ask the host system for, you can interrogate it and figure it out before the whole thing happens. So there is no surprise when it comes to these modules, and what they are requesting, and what they are going to perform in terms of action. So security is a massive concern these days because of the kind of sophistication there is in attack vectors and malicious actors. And WebAssembly fits in that groove as well for perfectly with its sandboxed environment. Now, despite all of these benefits, I'm really sad to say that it's not as hunky dory. I wish it was, but there are challenges like with everything in this union. So in a survey that was conducted last year during the time of KubeCon North America, um, there was the survey was conducted by CNCF only, and there were a bunch of questions asked, um, around WASM, its adoption, and what were the concerns around Cloud Native WebAssembly. So, a majority of people actually stated that the developer experience around the tooling that's there currently is sort of one of the biggest barriers that they are facing. And the confidence levels were confidence levels were low because the not the environment, the ecosystem around WebAssembly was yet to stabilize. So obviously, with maturity of the framework and with the evolution of the framework, this is going to happen. But currently, this was like the biggest barrier, like the developer experience being poor, and the fact that there was lesser confidence in the framework in general due to the lack of maturity. And one of the most requested things was, you know uh, obviously, one is the faster evolution of the framework, more maturity and better developer experience in the tooling. But WebAssembly in general is a polyglot. Now, why is it a polyglot? Like I said, it's a binary instruction format, right? So it's intended to it's the intention is to have different languages compiled to WebAssembly. In the ideal case, all languages compile to WebAssembly so that it can be distributed across operating systems, across architectures. Currently, we are not yet there. Like, a lot of official compilers for languages do not support WebAssembly yet. We are getting there by as the time progresses, but to reach that full evolution and to reach that level of confidence, and to better developer experience, obviously there is a requirement for more languages to be incorporated into the WebAssembly ecosystem. So these were like major concerns and what people would have liked from a cloud native WebAssembly perspective. But where do we go from here, really? So one of the things that I spoke about was, languages not really having support, like the official compilers for languages not having support. And that is one of the ways ahead, like more and more languages onboarding WebAssembly support for in their respective compilers. And the component model is a very interesting um, you know sort of, I wouldn't say innovation, but it's a interesting focus area for the WebAssembly ecosystem right now. And it promotes better code reusability. And that is another stream that is being worked on within the ecosystem. So an evolution of the WebAssembly ecosystem would involve um, the respective focus areas actually receiving attention and being seen to completion. Now, proposals, I was talking about various languages being onboarded, right? But most of the higher level languages have features like garbage collection and uh, you know uh, exception handling and stuff like that, and they are able to access memory in ways that WebAssembly modules are not right now. And as much as it is a benefit, it's also a limitation in some parts. And the proposals within the ecosystem that are there to further the initiative of evolution would really help, if they are sort of completed and made generally available. Most of these are actually being worked on right now, and they have reached a certain level of maturity, but it's a little while before it actually is available generally. Now, when we talk about bettering developer experience, there's no doubt that one of the ways that we enable developers to work more efficiently is by ensuring that there is a good package management tool available. We have one for cloud native, which is Helm. In a similar way, we experimented with a lot of tools in the WebAssembly ecosystem, but the true watershed moment came with the OCI registry announcing support um, for artifacts other than container images just last year in September. This includes the fundamental unit that I spoke about, those WebAssembly modules, and of course, there's corresponding work to be done in the WebAssembly ecosystem to make this a reality. But this is a huge step forward, because if you can store WebAssembly modules as OCI artifacts, it becomes a lot easier in terms of distribution and deployment. And last but not the least, I think serverless has been I want to say buzzword, but and not be taken out of context. But serverless has been like a really big buzzword ever since cloud computing came in. And anyone who's actually used serverless, to be really honest, I that was one of the very first things I tried, because I was like, what is serverless, and why is it named serverless? Like, does it involve some server somewhere? But yeah, anyone who's used serverless will attest to the fact that the whole thing is pretty resource and cost intensive. And like, for a person who doesn't know a lot about, please take it from a person who doesn't know about a lot about the serverless landscape, that it's also the function as a service is really resource intensive when it came to executing it on the various I think I executed it on AWS, but yeah, so it was resource intensive at that point. With, I think, WebAssembly, serverless is another direction that a lot of companies individually are trying to aim, their efforts at. I think Fermion and Microsoft have done some work in this space, and Microsoft has actually integrated Spin into AKS. So uh, that's one thing I think that's actually going to change up serverless, because WASM modules again are really tiny, not resource intensive. So thereby, obviously, because of their size, the cost associated will also be lesser. So eventually it all boils down to how much resources you're using, and how much cost are you incurring because of the utilization of those resources, and how many customers are you able to serve. So if serverless can actually get a big push in this direction because of WebAssembly, is another sort of prediction of sorts. But yeah, but I think how any of us could get started, or how anybody who's watching the stream could get started. Personally, I got started, like I said before, by watching recordings. If you like that way, great for you. But I heavily recommend actually getting involved in open source projects around WebAssembly. There are a ton of them. If you're like interested more in the cloud native side of things, there's landscape.cncf.io/wasm. There are 27 cards on there as of today. And it has like a lot of runtimes, specifications, installable platforms, things that you can get involved in. And if you're more interested in the core framework, there are projects in that space as well. And there's no dearth of opportunities, because open source is a space where you get to choose your own adventure. So it's all about where you start. And then last but not the least, there are a bunch of places where the WebAssembly community sort of congregates. There's a community in Twitter that I'm aware of. There are like there's a Discord also. I will I'll provide the links to Anais so she can actually post that in the description or in the comment section. But joining those communities is also very informative because, like I said, I'm the last person who should have been here talking about WebAssembly, but
Don't say that. No, no,
no,
no, you're giving a presentation about it.
yeah. So yeah, I should have been the last person because I did not have a background in programming, and I did not completely understand what was the whole hoopla behind WebAssembly until I actually started learning about it. So I would recommend, getting involved with the projects, to be really honest, because you can get your hands dirty. But if you're someone like me, you can do all the research in the world and then get started. That's also okay. Like, it's really how you choose to do it. But yeah, I guess that's pretty much it from my side. I hope that was a little bit useful,
That was
if not a lot.
amazing. Thank you. That was great. I'm going to stop sharing the slides, but we might put them back up if there
Yeah,
are specific questions or if you want to reference any of the slides to my questions.
sure. Yes.
If somebody who's watching right now live has any questions, then please do post it in the comment section, the Q&A section. I think you have to be subscribed to post there. So any questions you have regarding WASM, basically, do ask them there. I have several questions myself based on your presentation, like when I first saw it. Now you provided a little bit more context. Another one, I actually a lot more in addition to the slides, since I only saw the slides before. If you're watching the recording, then do comment the question below, and I'm going to make sure that Divya is going to answer them. I'm going to chase you up and answering all the questions. Amazing. Before we get to the questions, quick shout out again to Commodore and Arco for supporting these live streams, because they obviously take a lot of time to prepare, to get them set up. And I'm also going to donate actually some money for each live stream to women in tech focused organization. I haven't decided which one yet, so do give me suggestions if there's any particular one which work you really like that we should donate to. Anyway, so question number one. My first question was, what are the benefits? But you highlighted the benefits really nicely in this slide. If you're watching this, you can go back to the slide that highlights the benefits. So I'm not going to ask that question because I'm pretty clear on that now. But I was wondering, because to me, there's still this disconnect of like, I have my application. I know from the application how to build a Docker file and then build my container. And then I know how to get that container up and running in Kubernetes. Like I know this workflow, right? There's a step-by-step workflow that I follow. If you tell me there is, instead of having within my container application-specific dependencies, like we discussed earlier, like that, for example, make that container run in certain environments only. For example, we have at Aqua, we have a project called Tracy that does eBPF runtime and forensic stuff in your Kubernetes Cloud Native environment, and it only runs on, like it wouldn't run, for example, on a local cluster that you have on your M1 Apple MacBook. It wouldn't run there, right? It needs specific environments. So how would, independent of that project, right? How would I go about, I have my application, what do I do next to get it up and running somewhere? Like,
right, that's a very valid question, and I think I had this in my mind as well, because I used to work on systems engineering and middleware systems administration before I jumped into cloud native.
Yeah.
So I was like, how does this all pan out when you talk about it from a WebAssembly perspective? So to take a look at, so to understand this better, I will actually take a look at, like, I'll just describe a standard workflow for a traditional application, not even cloud native. We don't have to go so far as containerization.
Yeah.
So when you typically write application code, you have to package it in a particular format, and you have to place it on a server. That everybody knows. But when you place it on a server, there's also something that makes it accessible to users, right? It's not going to just like magically say from the server, hey, I'm here, please, access me. It's not going to be that. You have
Please
to have
do something.
yeah, so that's not going to be the case. So you need an environment that is like doing all the presenting to the presenting it to the front end for user access, or connecting it to the back end for maybe a database or a message provider or whatever. So that's going to be still there. And in the case of WebAssembly, it's the very same thing. Like that the only difference here is you will have your WebAssembly module. You'll probably write your code. The compiler of the particular language that you're writing in will convert it to a WebAssembly module. Now, once you convert it to a module, the question is, how do you run it? How do you achieve all those amazing benefits? So for that, you obviously also need to have an environment, which is known as a WebAssembly runtime. Now, there are tons of WebAssembly runtimes. You can take your pick. There's Wasm time, there's Wasm Edge, and there's a micro runtime. So there are like a lot of runtimes, just like there were a lot of middleware, proprietary middleware and open source middleware. There are a lot of runtimes, and you can use that as like jump off point for running your WebAssembly application. Now, your WebAssembly module, which is essentially your WebAssembly application. Now, how do you make those connections? Because, like I said before, the module is a sandboxed environment, right? Like it basically cannot access a lot of stuff outside of its tiny little sandbox. So for that, you have to actually compile it against its relevant WASI target, WASI. I am probably pronouncing it wrong, but I'm just going to say WASI target. And once you compile it against that, and give its empower it with the relevant network and file system access, it's pretty much the same as running a traditional app. It's not going to change a lot of stuff. So essentially what you're talking about is the underlying runtime. You have tons of them. You just have to go through the landscape. You will find, like, you just have to just like see, and you'll get the runtimes. But the host and the file system network and the file system access is what WASI provides as a specification. And these two together can sort of like help with the actual execution of your code and presenting it to your user, or connecting it to your database. In fact, actually, this is not a sponsored thing. Let me say it out loud. I don't know if anybody was there during Cloud Native Awesome Day any of the previous months, or y'all follow Fermion, but they have this really cool finicky viscous app, which basically is very cute. It's like a cat, and you have to feed it. You have to feed it. You have to keep on feeding it like food. And Matt Butcher, who's the CEO of Fermion, actually does a beautiful job of explaining how the whole thing works. So basically, TLDR is just that he has used the Wasm time runtime to actually deploy his WebAssembly modules. There are around, I think, 7 WebAssembly modules that connect to a backend database. When you actually hit the app, one WebAssembly module is responsible for downloading the files onto your browser, and there are several modules within that perform different functions. One is for sort of um, you know leaderboard and stuff like that. So there are a lot of different things, but you get the gist. So there are like different applications, and you will have like a runtime environment where you deploy them and it sort of executes. Does that answer your question though?
Yeah, it does. But now, like in my mind, I think about runtime similar to like if I guess probably completely different kind of capabilities, but kind of if I deploy a container to Kubernetes, of like having kind of a layer of it. Obviously, that's different, right? Different, right? You have different components.
So technically, when you say runtime, it's very similar to container runtime. I
Yeah.
wouldn't say it's like a like for like. It's not an absolute
It's
parity.
like from the workflow.
Yeah,
It's
yeah. Yeah.
okay.
In fact, that's how I think. That's probably going to even that's probably how actually a lot of the container, how do I say, how your WASM workloads can actually be run inside a container. Inside a container, that's
Yeah.
also how it works. So essentially what happens is you have a container manager, like that simplifies everything. Like Docker is one of the most easiest ones here, so I'm just going to refer to Docker. But Docker is like, the one thing that everybody knows, irrespective of whether you know containerization or not.
Mhm.
So Docker sort of is one of the things, but underneath it you have like your container d runtime or your mobi, whatever. It's the higher level container runtime, but the lower level container runtime is something like run,
Yeah.
or I hope I'm pronouncing it right, but this is my pronunciation of it, and it's
Run
what it's
C,
saying.
right? That's how
Yeah,
you
run.
pronounce it.
Yeah.
Yeah.
So if it's rank, I do not know, but I think it's
I
run.
hope people don't pronounce it as rank.
Yeah, it's already wrong, but in my head it's Runc. So
Yeah.
Runc is one of the container runtimes, and basically it's the lower level one which spins up the containers. But essentially, you need something to manage everything. So you have container D on top, and the way these two communicate is via container shim. And if you're talking about WASM workloads, you, instead of the container runtime, you have the WASM runtime, and you have, instead of the container shim, you have the WASM
Yeah.
shim. So that's the only difference. Like, I mean, implementation wise, there's a
Yeah.
lot of code difference. I'm not going to say that's not the case, but from the
But
perspective,
from a high
yeah,
level, from a user perspective.
yeah, yeah.
Cool. I was just, you broke up, so I was waiting if you want to
Yeah,
add
yeah. No, no,
something.
no, 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 no.
Awesome.
Yeah.
Great. If anybody has some questions, do post them in the chat. We have about 10 minutes left. Otherwise, I'm going to ask another question. How big is the space, like specifically to Cloud Native, right? To the Cloud Native wasn't space. How many projects are there? Like, how large is it? Like how
Good
many
question.
projects are working on problems related to WASM for Cloud Native projects, and focus really on those topics, right?
So, like I said, landscape.cncf.io/wasm will give you like 27 cards as of today.
Okay.
But there are also like projects that leverage wasm for doing stuff in the cloud native space. There's Kubernetes, which is, I'm again not, I work with them, but I work with that
You're
project,
not
but it's
promoting anything.
yes, not promoting anything here. I'm just saying that it's one of the projects. It's on the
Yeah.
CNCF landscape. It leverages WebAssembly to sort of write admission policies in different languages instead of Rego. So that's one thing. But
Mhm.
then there's also OPA, which already has these policies sort of compiled to WebAssembly and made available, for user. Like the logic is already written. Like with Kubernetes, you can actually write the logic, customize it yourself, and sort of convert it to WebAssembly modules, distribute it. But with OPA, you have you have the WebAssembly support already there. With like the logic is converted to WebAssembly, you can just use it out. That's one thing. Those are two projects I know of. Then there was Crustlet. Crustlet was um, very different implementation of WASM workloads running natively on Kubernetes. It was
Mhm.
essentially like we spoke about right now, right? That there's this container D, there's a container D runtime. There's a high level container runtime and a lower level container runtime, and there's a shim and stuff like that. Chrysler took a different approach, and unfortunately, I don't think it's like very actively worked on. I think
Mhm.
it's there as a project, but I'm not sure how active it is. It had a different approach of using a Rust implementation of the kubelet, which is the node daemon. And essentially, what this would do is schedule pods based on certain taints and tolerations, and they would be scheduled on your WASM runtime instead of like a container runtime. So that was a totally different
Okay.
approach, and that was a thing that was there when I started out, like I think 2 years back.
Yeah.
But I don't know if that is actively done. Like I don't know if it's actively maintained. But other than that, there's Envoy Proxy, which also has a fair share of WebAssembly stuff going on in
Mhm.
its project. There's also, I think, uh, which way I was going to say the project name. It just slipped up this
Ah,
thing, but
that happens.
yeah, so there are a bunch of projects slowly onboarding support,
Yeah.
but yeah, even in fact, c run, right? I'm not sure if it's cran now, but it's c run is another container runtime. So it has WebAssembly integrated at the OCI layer. So
Mhm.
that's another thing that's supported. And
Okay.
yeah, so there are a bunch of projects doing things in the WebAssembly space, and then there are a bunch of projects leveraging WebAssembly for different, needs and wants in the cloud
Yeah.
native space. So yeah.
We have a question. Is there a playground to learn and explore WebAssembly?
um I am not aware of any such playground. I do not know, to be really very honest. But you can sort of, recreate a playground on your own. This thing. That's how I did it. I
Yeah.
am not aware of a playground so far. Like, I know that you can actually run the finicky whiskers thing and see the output, but I know that you can't actually also, you know, it's not a playground. It's just a demo that, this is built on
I,
WebAssembly. It's not a demo.
yeah.
Yeah.
I guess it's a little bit more difficult to set up a playground for that than, for example, if you're learning Go and you're
Yeah, that's the thing.
trying
But
out to something.
also there was
Mm.
one. So there was one, but that
Mhm.
was for JavaScript as far as I remember, and it got sort
Okay.
of, yeah. So it's I think it's no longer live. I was trying to use it for one of my demos last year. That
Yeah.
time itself, it had just gone off. So I don't think it's live anymore. But there was one very uh, good website where you could just like write your code, and you could see it actually compile to WebAssembly. You could see the binary and the textual formats. That's how I realized that there's like an actual thing happening behind the scenes. So that's one thing.
Mm.
But you can actually, if you're comfortable, with cloud native stuff in general, like I won't say intermediate level of proficiency, but even basic level will do. You can actually go ahead and get your hands dirty with one of these projects. And I think most of them also have like some sort of mentorship in like the Google Season of Code or Outreachy or LFX. So that's another great way to get involved. But as far as I know,
Yeah.
right now there's no playground. But I could be wrong.
I
Not
just
gonna say.
googled it and
Yeah,
it doesn't seem like there's like, there's the Go playground where people like
yeah, yeah,
learn bowling, but there's not like the Wasm playground, it seems.
yeah, yeah, yeah.
Um, I found a project, but it's basically a GitHub project. I don't know. I don't want to post in the chat because I didn't look through it. But there's maybe something you can find. But
Yeah,
yeah, try out maybe the getting started guides of different projects that are using Wasm.
yeah.
Um, that's a good idea. Awesome. Cool. If there are any other questions, if you're watching the recording, do post them in the comment section and we will answer them afterwards. Divya will answer them afterwards.
Yes, I will.
Amazing. Well, we are close to the end of this live stream. Thank you so much for coming on and giving this presentation, answering my questions and the questions in the chat. That's really great. Thank you so much
Thank
for
you for
taking the
having me.
time, right?
Thank you for having me on. I was really great to catch up with you, and I hope we can catch up at KubeCon as well. I
Yeah.
know it's going to be crazy. It's going to be
Yes.
like really, really crowded and stuff, but I hope we get to catch up there as well.
Yes, definitely. Let's aim for that. And
Yes,
if anybody sees us at KubeCon, do say hi, please.
yes,
Say hi.
yes,
Say hey,
yeah,
you watched the Wasm live stream.
yes.
Amazing. Awesome. Thank you so much. And again, thank you so much to the supporters of this live stream, Commodore and Aqua. Thank you for giving me the time to work on these live streams and set them up. Yeah. Awesome. Thank you. I hope everybody has an awesome day and to see you in the next live stream. This live stream is part of a series where I invite amazing women in the cloud native space to She Can Cloud Native to talk about topics that they are interested in the cloud native space. Thank you, Divya, again for coming on.
Thank you for having
Amazing.
me.
Bye-bye.
Bye.